Okay, yeah, I think we'll get started because the recording has also started. Now, coming to the denial of service and distributed denial of service, as we have seen yesterday, as part of the entire topics of the attacks, these we will be try. We saw that how these kind of attacks are able to target different types of resources, right? So it could be your machines and your laptops, your networks, right? Where they will try to uh, make you understand or make you feel that these are some kind of a legitimate requests which are being done, and this because of which there could be service disruptions, there could be monetary losses also that it starts on happening. Now, based on the locality of, so one another way how you can define whether the DDoS attack which is being identified, or being launched, it could be a more of a local kind of a DDoS attack that you can have. You can also have some other categories of DDoS attacks where it will be a more of a remote kind of a DDoS attacks, right? So local kind of DDoS attacks, and a remote kind of DDoS attacks. Now, local kind of DDoS attacks are more where, the target that you have when the attacker is launching this, you'll see that there could be a specific system or there could be a underlying host that is being targeted, right? So, for example, let's say you have a database. Let's say, for example, you have a SQL Server database, and there is a specific instance of this that is running, right? Now, what happens is the attacker can choose to stop this kind of a service or can also try to change this configuration in such a way that any legitimate users or any legitimate request and all would also not be possible to take that. So there is a kind of the attacker can try to identify if there is a specific service that is running, try to bring down that service in such a way that that entire database can come down. So you can see, like, for example, there could be some kind of a vulnerability that could be exploited within the entire database. I can identify that exploitation for that SQL service, and then I can create a denial of service attack for that, right? That is more, I'm trying to do a more for a specific service, right? Another thing that I can do is, like, for example, I can do a local attack. Let's say, for example, I can identify some kind of hardware resources that could be exploited, right? So these hardware resources could be having some kind of a specific task and all. Like, for example, I can try to make this resources start over consuming the memory, hard disk, so it is normally when you try to go to your resource manager and try to identify what are the resources that are being utilized, then you will start seeing that there is a kind of higher memory utilization or huge number of hard disk is going to get because the files are getting deduplicated. So this kind of the system resources could be overexploited, right? Like, for example, you might have seen some of these there could be some kind of resource intensive task that you can see that it can start coming in. So where a lot of these, tasks could be identified. There could be aspects where, all the resources are being employed only for that, and there will be not any space resources that would be, right. So one kind of thing that you might have heard about is, creation of rainbow tables, right? So like you have certain kind of pre-computed hash, right? So one technique is, like, for example, how you create a rainbow tables, right? So using my Windows thing. So rainbow tables are normally used for recovering many types of password hashes. Like, for example, you have these MD4, MD5 kind of algorithms or SHA kind of a SHA-1 kind of a, uh, password things, right, which are there. So these rainbow tables are more like a lookup tables you have. So these lookup tables would be useful for comparing all your passwords, password hashes, how these password hashes would be useful, uh, how these password hashes would be useful to generate the password for recovery, right? So these passwords might be mostly stored in in some hashes, and when the machine is trying to store this password, there could be one kind of a hash of this password that would be there, right? Now, what happens is these rainbow tables primarily, if you see, would be working on this entire principle where there is an underlying principle where it will try to see that there is any kind of a memory kind of a trade-off that could be looked into, right? Uh, so there would be kind of a less computing processing time that might be useful, right? Or more computer storage would be useful for. So when these there could be some kind of these dictionary attacks that happens. So what happens is when these right, so there could be a hash that would be calculated or created at every of the attempt, and more processing time would be required, as compared to that normal scenarios that we'll be having. Right, so there are different ways these different rainbow tables could be generated, different encryption types you can use, right? So rainbow table is one example where excuse me, resource intensive task could be being used for. Their task would be a more of a resource intensive task, because for each of these tasks you can see that there is a hash algorithm that would be used, that would be created. So that is something more of your resources will get utilized. Then you'll see that there could be also times where there as part of my Bruce Force attack, there could be some kind of a password cracking that I might be doing, right? So another kind of a scenario or example would be where you see the brute force for password cracking might be happening. Now, brute force password cracking, as we have seen, where you can see that there is a kind of a trial and error that would be done for the login, right? So this trial and error for the logins might create a lot of, um, different iterations. You can say that since there is a brute force that is being used, there would be excessive forceful attempts that would be being done. There would be, some kind of multiple times that it would be going into iterations, different combinations would be tried in, right? So because of which also a lot of resources you will be seeing that getting utilized, right? So you'll see that some of these, sometimes it might be that your the web pages might be tried to be redirected to some other pages, or some other multiple websites starts getting open up in multiple tabs. So all these kind of different types of brute force attacks can start happening. Dictionary attacks like is one of them. You can see that there would be some kind of a hybrid combination of them where there's a kind of a blend and different types of logical guesses that would be in combination would be tried out as well to attempt these brute force attacks as well. So this is another scenario where you can see that there would be a very high resource intensive, the resources would be utilized. Then just Then, for example, you can also see that, there would be also a time where large number of files could be multiple being utilized, right? So because these large files are opened at the same time, you will see that there is a very high consumption of memory. The system might stop working because the entire system gets utilized, system memory starts getting utilized for, opening these files and all. So you'll see that the attacker can deliberately try to execute a lot of these tasks, so that they can start exhausting the resources. They can, there could be they will be using some kind of malware programs like your bots and all, because there would be some kind of an iterations and all. So you will see that some kind of bots, viruses, or worms would be injected into the system, or injected into a network that can start creating or utilizing a lot of these, to execute this as this is something that is normally being used. Then the other thing that you will be seeing is, this is one category of DOS attacks which you have. The second category is mode, which is like a remote DOS attacks which you have. So in a remote DOS attacks, what happens is you will see that any kind of a protocol that you will have, like for example you have a acknowledgement and a sync kind of a flooding that might be happening. So what happens in this, this is primarily where a kind of a protocol attack can be. We have seen what is a protocol attack. So there is a protocol attack that might be executed for a specific kind of a protocols, like a flood of SYN an acknowledgement, kind of a flood that might happen where you will be trying to see that it would be the protocol would be, thing. Similarly, on the application layer, you can start seeing that there could be some type of HTTP gets or HTTP post that can start happening, right? Because of which the HTTP gets and the post can be leveraged so that some the resources could be exhausted. That could be happening. There could be a volumetric attack that could be happening, right? So the volumetric attack could be happening. Like for example, we have seen that uh, you know what are the different types of how you can have a flood. Yesterday we saw what are these different types of volumetric attacks that would be, could be executed, right? So for example, we have the UDP and ICMP flood attacks, right? So where we have seen that the entire packet drops might be happening. The packets would be that is getting exchanged could be creating a lot of these things, right? So the protocols which are being utilized, how these protocols are being utilized for your data transfers. So these are primarily the another could be a category of these that could be useful, right? Now a list of all these, what are these list of all these attacks that we have, all the DDoS attacks that you have. What are some of these? You can, you will see that how they are primarily being utilized, as part of your entire things. So there are different types, different categories of these, attacks that could be happening, where you will see that, um, these could be utilized. They could be, identified, or first you need to see what are these different types of things that we'll be having as part of. So we saw a complete list of all these different types of attacks that are there. So these are some of the things you have. Within this, you have, like, for example, we have seen the fragmentation attacks, how this entire thing would be working. So in a, let's say, for example, in a SYN kind of an attack, like, so let's say, for example, there are multiple types of users which are there. So like, for example, you have a user one, you have a user two, right? There is an attacker who is coming up. So these user one, user two, they are trying to access this server. For example, this is a server that you have, right? Now, what happens is all of these, there is a kind of, uh, you know, synchronization message that is being requests that is coming to these different users, right? And in between, there is an attacker who is coming in, right? So every time this, the target that you have, okay? So this target server will be receiving this SYN packet. It will try to respond with an acknowledgement, and it will try to set a kind of a timer. So as there is a final acknowledgement packet that might have to be received from this, so there is a kind of an handshaking that is happening over here. So there is a kind of a three-way handshake, which you will see, which will be basically useful for my communication. Now, if you see the attacker primarily over here there is an attacker, right? So this attacker might never send any kind of these acknowledgement packets, right? Because what happens is there is a request, there is a response, and then there is a confirmation that goes as a part of a three-way handshake. But the attacker normally will not give any kind of normally the confirmations. So what happen is the the packets that will there will be continuing to be sent, so that it is able to fill this destination server's connection queue. It might not be allowed to be accepted by other SYN packets also, like from the other users. So normally the attackers will try to spoof this source IP address in such a way that, the response traffic from the target devices that you have, they are not reaching that entire system, right? So there would be some kind of a connection request, reset that would be happening. And because of which, you'll see that there will be, uh, you know, the initial SYN request that has been gotten, it will not be able to give that a connection request. So what happens is it will just allow my target system to remove any kind of an entries, from the connection, because of which the connection would be queued more faster and the attack could be less attack. So that kind of a method that we can do that can basically help us to avoid the SYN kind of synchronization kind of a flood attacks. So this is a very industry practice that you'll see where you will could be trying to define these, we will try to flood the system, and but that flooding is something that we want to disable it, right? So some of the other ways that you can try to prevent these attacks is, like, for example, you can have an proper kind of the three-way handshakes is that is happening, right? So we can try to have, right? So first thing that you can do is you can have an intrusion prevention system. So this intrusion prevention system can try to detect any kind of anomalies and the traffic patterns that would be coming in, right? So that would be happening, and then because of which it can try to block my malicious packets that will be coming in. So it will try to block the packets, right? So it's a kind of a first line of defense that you'll see as part of my, SYN attacks. And if, let's say, for example, this intrusion prevention system is trying to detect any sudden surge in the SIC1 SYN request, that means that, and this sudden surge is happening from only one specific IP address, then there is a kind of indicator that it is more like some attacker is trying to manipulate that. There is a kind of an SYN flood attack that has happened. Now, once it identifies that there is a SYN flood attack, then because of, I can basically try to, because from this single IP it is coming in, so we can try to, the intrusion prevention system can try to block before the request from that IP. It will stop that. So that's the first thing that I can do. The second thing we can do is, we can basically also have some kind of an on-site firewall. We'll try to configure the on-site firewall for the SYN attack. So in this, what we'll do is we will try to have some kind of a threshold that we can define, right? So as part of my SYN attack. So as part of my SYN attacks, what we'll do is we try to have this, for every client and server configurations that we have, right? We'll try to have these kind of we'll try to have these thresholds defined. Now, these thresholds primarily can, limit my incoming traffic. They can block my connections, right? I can limit my traffic connections, right? The incoming traffic connections that I have. I can block some of my block the connections, right? Any of these, if there is any kind of a suspicious or malicious IP addresses, then I can also block them. Then we can also try to set and reduce the timeout that would be there. Let's say, for example, there are some kind of my half open connections. So these half open connections are something that I can try to, reduce the timeout for them for these connections and all. So because of which there would be, I can try to mitigate the SYN flood attacks as well. Next, I can also do is something I can do is I try to install, some kind of installation of some networking instruments or equipments, the up-to-date ones, which has certain kind of rate limiting capabilities, right? So this rate limiting capabilities helps us, what we can do is there is some kind of a built-in rate limiting capabilities that we can think of, because of which the SYN flood attacks could be avoided. So we can have certain limits defined with respect to how much SYN request can come in, and all. So the server will be accepting how much number of swine requests coming from a single IP address of the specific time frame. So all those kind of things I can do it very easily as part of it. Then there are certain kind of, I can also start using any kind of, I can use a monitoring tool and all, because using that I can be able to identify, so installing some kind of a monitoring tool will also be helping me provide a visibility about my entire network. I can analyze the entire traffic patterns, right? And I can identify and indicate what is the kind of an attack that is happening in case if there is a sudden change surge in the request, right? So these are different ways, the S1 flood attacks could be coming in. We can try to have this. Now, normally the attackers, if you see, they will use certain kind of spoofed IP address. So these spoofed IP addresses that you will have, they can basically ensure that the response traffic that is coming in from these target devices, they are not able to, reach a specific working system, right? Because of which there is a connection reset that might be happening. A connection reset might be required as well for these connections as well. So in that case, primarily what will happen is you might have to reset, you might have to try to restart this entire, details of establishing the connections. You might have to basically redo that entire connections. Then you also have the, ACK, the acknowledgement flood attack also. So acknowledgement flood attacks, just like you have the, entire our SYN kind of an attack that we have, right? Similarly, you also have the ACK kind of flood attack. So wherein we are, we also see these attacks as some kind of a, again, a category of flood attack that it has. But what it happens is while we are having these under your remote DDoS attacks, we will try to um, here you'll see the primary target that will be there, it will be more with respect to any devices, you know, any devices which you have that would be more like your firewalls and your servers, right? So these are more like states, as part of your state in devices, right? So normally the ACK attack is being useful for or being targeted. Those devices are being targeted where you'll see that, these are they are trying to disrupt the entire network activity. They would be trying to, disrupt my entire network, right? So what happens in this is there is a kind of a bandwidth utilization, resource utilization that would be happening in some of these devices. And since there is a kind of a continuous acknowledge that is coming up, there is a kind of acknowledgement packet that would be coming in towards the target state. So sometimes the entire, the defenses can go down and there is a kind of a flood because of this flood of requests coming up, right? So you'll see that this would be useful, it could be utilized, right? Now, primarily, if you see, there are different types, these flood states that will be there, could be coming in. So these packets, the acknowledgement package that is coming up, right? So as I was mentioning with respect to these different devices, like for example, the switches, or for example, routers and load balancers might not be very, the right, targets. So in this kind of an ACK acknowledgement attacks, because they don't really need to have like any kind of a payload. The attacker goal is to just try to generate some kind of a traffic, and because of which they will be, completely over loaded or, overwhelmed with these kind of requests coming up. So normally these kind of things you'll see that where the acknowledge ACK attack is very common in a network kind of thing where it is unable to distinguish any kind of valid acknowledgement, distinguish any kind of a valid ACK traffic, which might be there from your illegitimate packets. right? So that might be there. So similar to your the SYN kind of a flood attack, here also we are trying to have some kind of a spoofed IP address, right? So spoofed IP address again would be used more over here, and we would be trying to make the entire network feel that there is a kind of thing, right? So packets, things will be there. Again, there is a kind of a three-way handshake over here because primarily, as we have seen, you know, in three-way handshake perspective, you have a synchronization, then there is a synchronization acknowledgement, and there is an acknowledgement, right? So the acknowledgement packet that is going off as part of this, here we will try to because of as part of my three-step handshake perspective, the last two steps are where you have these, and the last step is primarily the attack is there. So we will basically make this, the entire attack looked into in such a way which is part of my entire layer 4 kind of. So in my layer 4 of my OSI kind of a model, you've seen that we have the transport layer. So this is where the entire things happen, right? So we will try to, uh, you know, have these kind of have identification where there is a kind of an acknowledgement that is coming in. We will flood this entire request, because of which it would be very difficult to identify these packets. We might be looking for similar packets in the attacks, but which of them is the genuine packet, which of them is the where the request would be coming in, or we will not be able to identify, that becomes very hardly, difficult to identify. So those kind of things you'll see in these kind of attacks where with the users, the acknowledgement attacks, which might be coming in. Then we also have the other type of attack, which is a fragmentation attack. So fragmentation attack is more where, you will be trying to see that, the entire fragmentation layer that, as part of my IP ICMP, right? As part of this fragmentation, it is more like you have this IP fragmentations, which we were looking into, right? So the IP fragmentation, where we will be trying to look into how these packets, the IP packets, they're being fragmented, and then they gets reassembled, right? So this fragmentation and then reassembling of these, is where um, the attacks might be, the attackers will be trying to have these, right? So yesterday we saw that how the attackers will try to manipulate the fragmented packets, because we have the offset, the trigger vulnerability. So that is again, as part of the fragmentation attack, we will be, occupying this target, the final target, which is we want to compromise, which, we will try to have some of these routers and firewalls and which are primarily trying to pass my entire traffic across my network. We will try to expect the reassembling to be done right at the receiver end. But let's say, for example, the reassembling packets is also constantly changing, right? So this, because of this reassembling packets continuously changing, or it is continuously happening, what happens is you'll see that the device would be getting overutilized, right? So, and this is what we try to do. Our whole aim is to start you overutilizing these resources. We can, and during as part of this overutilization, this would be getting impacted. So, this kind of packet content randomization is happening by the attacker. We can start have these additional resources that starts getting, the additional resources would be start getting processed. So sometimes you'll see that because of which the targets might be entirely crashing it. So these are different types of, another kind of an attack where, as part of my remote attack, I would be trying to, attack these things. Now, as we have seen, the APIs are getting a lot of popularity. So what the attackers are also trying to see is how they can start looking into some of these, the way entirely the communications that is being utilized for APIs, right? So for that, you can see that There is another category of attacks that which is very popular, which the attackers, which is your application layer attacks. Now, like for example, now because of the connectivities, the application layer itself, where the attackers can start thinking of the way the communications are happening. So the application layer is primarily where we want to make this entire application disconnected from the network, right? So it would once it is disconnected or is being disrupted, we can start have these attacks identified. So we see some of the common ways of we have seen is like for example the SYN attacks, the SQL injection attacks that might be happening, or the cross site. So some of these that we have already discussed, these attackers would be trying to do that. So what happens is, as part of the application layer, you can see that I can start having some kind of these additional requests coming in, right? So the HTTP gets and posts, that is part of my API calls, right? So get is to get in the data, post is to post any kind of a data. So the attacker in this kind of a scenario might try to target these target web servers, right? So so where what will happen is there will be multiple types of gets or multiple number of gets and multiple types of post requests that keeps on happening, right? So because of which what happens is the entire server gets completely overwhelmed, right? The server, in that case will not be able to understand, all because of this multiple request. And this request that would be coming in as part of the gets could be for normal text files. You will get it for images, you will start seeing it for any kind of videos or other kind of objects, because, it's an API calls. Now, because of the type of the API calls and multiple types of API calls, what you'll see that your entire, the network would be getting choked out, with respect to these different components, right? So, as part of this, you see different types of attacks coming in. So you have the slow release attacks. So in the slow release attacks, you have something like a partial HTTP request that would be happening. So you have a partial HTTP request that would be happening, because of which there would be multiple types of open connections, you know, between the computer, between the machine, there could be between the target web server that would be happening. And this is where, you're trying to overwhelm the entire target to slow down, so overwhelming of the entire target might be happening, right? Then this is one kind of thing where you see the slow race attack happening. Then you also have yes, yes, we also have discussed one other kind of attack where, the entire protocol kind of an attack, which is your border, gateway protocol, the hijack attacks that might be happening also, where I would be trying to, falsely claiming the ownership of some of the group of IP IDs and IP addresses and all, right? So those kind of things I will start doing it as part of my additional application layer. So this will be there. Then across the application layers, we have seen the SQL injections, SQL injections and all happening, where, because, it will be there. Now we can sometimes see that the attackers might be using botnets also. So the botnets would be useful. Normally, since there is something multiple requests that would be there, right? So as part of these requests and gets and posts, we have these botnets which will be trying to have these the entire attacks coming in as part of the entire things. It will be completely getting to choked up with respect to the request and the response that you might be getting it. So these are another kind of an attack that you will be seeing, where that is a very popular that you'll be able to see. Now, the other types of categories of attacks, which we have seen as part of your denial of service, is primarily like your volumetric attacks. So in the volumetric attacks, we have seen that, there could be entire floods of request and the response coming in. So one kind of there is primarily your, the UDP kind of an attack that we have, which is more where, the entire user datagram protocol packets would be utilized. So that is one category that we'll see. We have the entire user datagram protocols or the UDP coming in where the packets are being sent to the target server. There is a kind of an overwhelming that might be happening as part of the request and the response, right? So you'll see that the firewall might be trying to protect the server, but then it also gets exhausted, because of the user datagram protocol packets that is being sent, and that might be creating or resulting in a denial of service also. So normally, if you see, like if there is a kind of a how this entire UDP works primarily. So what this UDP actually does is it tries to exploits, what are the steps that are being taken, by a server. It exploits what are the server might be trying to respond, right? So when it tries to respond to the UDP packet, so what are the process that it goes? So it tries to explore that, and it tries to try to take advantage of those, right? So what happens in a normal service conditions, if you see, if there is a server, this server might be requesting a kind of a UDP packet at a specific port, right? So this UDP packet which it would be getting, it goes to different two steps, right? So in the first step, what happens, the server will be trying to check if there is any kind of a program that is being running, and it's currently requesting listening for all these requests, right? So it will try to check you know these aspects, the if the program is running, and if there is if there is it is listening for any kind of request, right? So that is the first thing it will do. The second thing is, let's say for example, if no, none of these programs are receiving those packets, right? So what happens is, in that case, the server would be trying to respond with a kind of an ICMP kind of a packet, right? So it will try to inform the sender. This ICMP packet is nothing but where it will be trying to inform the sender that the destination was not reachable, right? So you can consider this very similar to, like, for example, you have a hotel receptionist, right? So this person which is there, this hotel receptionist is trying to receive a call, right, from a person. Now, this caller who is, this person, this is the receptionist that you have. Now, this person who is my caller is trying to call this receptionist. And first, this receptionist will receive this phone call. It will ask whether, whether they are calling from where and the location is. Now, the receptionist need to look through all the list of rooms to see which of these guests the guest wants to make a room booking. So, they would be seeing which of the room is available. Or let's say, for example, in case if there is a call coming from other person for a person who is already staying in there. So which of this person is they have been trying to reach, and then we'll try to connect them. So let's say, for example, in case if this person is not, is taking any call because they have disconnected, or, then they will try to see if there is a kind of a backup phone number for that guest, and tell the guest, the person who is calling that, the guest is not taking any request, and, you would try. So normally, if you see any kind of these requests are more like these UDP packets. So once these UDP packets are being received by the server, it primarily goes to an entire steps where, it might be utilizing the server resources, and each of these packet might be, will be including the IP address of the source device. And normally we'll see that, the attacker will normally not use their own real IP address, that, let's say, for example, this person is calling, so they will not call from their own phone numbers. So what they do is, they use some kind of a dummy IP address or some other spoofed IP addresses, because of which the attacker's true location might also be not exposed, and the response packets also, if I want to target, or if I want to, mask that, that becomes very much easier. So as part of this, normally what I'll do is, I, as an attacker, I might create a bot. Okay. which might be using some other IP addresses, and I will try to send some kind of these spoofed UDP packets to my target, right? So this target primarily will be then getting all so many number of requests, and the target server primarily will start responding to a lot of these requests, because of which the target resources would be completely exhausted, because there is a large flood of UDP packets that are being. So because of which there would be a complete denial of service. Then for the normal traffic will not be able to. So that is one of the things that you will be able to see. Now, one of the things that you can do is you try to limit or change the configurations of my response rate. So you try to limit your response rate, right? Of my ICMP packets that you might be getting, so that you can try to avoid these DDoS attacks. So the only thing is, when you're trying to do this limit the response rates, what also happens is even for your legitimate request and all packets also, that might also get impacted, right? So because there might be a huge volume that might be coming in, and of requests that would be taken care. So the entire system will also start slowing down as a whole, not only for on genuine, false requests, but even for genuine requests. So that is another one of the disadvantage of this kind of the user datagram protocol, the flood attacks that would be where you will be trying to limit the response packets, as part of the entire thing, right? Then there is another kind of a scenario or another kind of an attack that you might be, seeing which might be, um, you'll see that that might be creating another kind of an attack, which is primarily your DNS amplification kind of an attack, right? Now, in a DNS amplification attack, what happens is this is again, where the DNS resolvers could be utilized to, make the entire victim understand, right? So normally, if you see a typical message in a DNS amplification, how these entire aspects work. So let's say for you have an attacker, right? In this scenario, you have a attacker. You as an attacker, you are there, you have a bot, right? And then for this target that you have, there are different DNS resolvers that you might have to resolve the conflict. So you have a DNS resolver, that, for example, the request that is going to the target. So like this, you will have multiple of these DNS resolvers. Now, in this DSS kind of an attack, what happens is the open DNS resolvers would be, the attacker will try to leverage this functionality so that I can start overwhelming the entire target server with an amplified amount of traffic, because of which the entire server and the surrounding infrastructure could be made inaccessible. Now, all of this, again, it's an amplification attack, right? So what I'm trying to do is I'm trying to amplify, right? So there would be a kind of a disparity that I might be having in my bandwidth consumption, right? So for example, the bandwidth consumption, the disparity which I might be having in my bandwidth consumption with respect to my targets and the targeted web resource that might be there. So this gets magnified, this gets amplified, right? So across all my requests, many requests, there could be, I will be magnifying, I would be, trying to amplify the overall request. So the entire volume of traffic might be disrupted, right? So what I'll see is I might be sending some small queries, I would be sending some of my small queries and all, but because it might be resulting in some kind of large responses, right? Now, because of which the user might be able to, get a lot than what is being expected, right? So there is a bot that I'm using. It will keep on generating a lot of requests, So the attacker might be, taking use of a very small network and all. It will start getting it things. A lot of these network congestions it will try to have, right? Let's say, for example, let's say you'll see that let's say there is a kind of a person who is just calling a restaurant, right? And they are trying to say that, let's say, for example, I want you to please call me back, and I want to place an order. Now, let's say this restaurant is trying to call this person. Now, what happens is, this target is then being, you'll start seeing that this person starts receiving n number of calls from this restaurant, right? And because of which, they would be completely, their entire phone would be complete. So you'll not even understand what is a right call and what is a wrong call, right? So because of each of these bot making requests to have these, resolver with a spoofed IP address, so you'll not even understand which is the right IP address or the spoofed IP address. There's a huge volume of traffic that might be coming up, happening. The attacker might be structuring this request in such a way that, it might be generating very large, response from the DNS resolvers, right? So the target might receive an amplification of this initial traffic, and the network becomes completely clogged out with some of the spurious attacks traffic as well. So that is another kind of thing. So if you see, the entire attack could be broken up into 4 steps. So in my first step, the attacker would be trying to have a kind of a compromise endpoint. So in this compromise endpoint, they would be trying to send my UDP packets. I might be using a spoofed IP address for this, right? So I might have a spoofed IP address to a DNS recursor, right? Then the spoofed IP address that I might be having on my packets might be pointing to the real IP address as well, right? So that is the first thing I will be doing. Then each of these UDP packets that I would be taking in, might be making a request to this DNS resolver, and I might be trying to pass an argument, like for example, which is the argument that needs to be used for receiving the largest response also. So that is the second thing that I will do. The third thing that I will do is, after I try to receive this request, right, I will use the DNS resolver that will try to help in sending a large response to the spoof IP address. So I will try to send a large response to my spoofed IP address. And then port is where the IP address that I have, the IP address of my target, I will try to get this response. I will try to receive this response, and, of this as well as my surrounding network. So this becomes completely overwhelmed because of the traffic that I will be having, and because of which there would be a complete denial of service that will be happening. So how do you mitigate this kind of an DNS amplification attack, right? So let's say, for example, as an individual or as an organization, you're running a website. So in that case, some of these attacks is, the individual server might be the target by the attacker, or, because of the high amount of traffic, the ISP, the infrastructure which is surrounding the server might be impacted, right? So you have the ISP, the internet service provider, or the upstream infrastructure provider. They might not be able to handle this incoming traffic, you know. So what happens is you have these ISPs, right? Internet service providers, they might try to have a black hole. So all these traffics would be black holes, put into the black hole to the IP target IP address. So because of which it would be trying to protect it. So the target would be trying to be protected, and this targets, could be there. So that is one thing that it can do. Second thing that it could do is it can try to reduce my total number of open DNS resolvers. Now, as part of this, what happens is, as part of my DNS amplification attack, that is able to access, these open DNS resolvers. So let's say, for example, having a poor configured DNS resolver that could be exposed to the internet, what the attacker might be, needing is to trying to utilize this DNS resolver to discover it. So ideally, these DNS resolvers, you'll see that, in a most likely case, they should be more provided with, services to devices that is originating within the trusted domain. But in case of these reflection-based attacks that we are seeing, what happens is the OpenDNS resolver base trying to respond to the queries from anywhere, right? And because of which, it will be trying to completely flooded with it. So what you try to do is in these kind of a situation, you will try to restrict my DNS resolver so that what will happen is it will try to only respond to the queries that are there from my trusted resources. So I will try to make my trusted sources identified, because of which the server, can the amplification attacks could be stopped in. So that is one thing that you can do. The another thing that you can do is you can have a source IP verification. So source IP verification is where you will try to stop my spoofed packets which are being leaving the network, right? So what will happen is these UDP requests that are being sent by the attacker's botnet, they will have some kind of a source IP address, right? Now this source IP address that you have, they might be spoofed in to the victim's IP address, right? So because of that spoofing of this victim IP address, uh, you will see that that might be also reducing the effectiveness of my entire UDP-based amplification, right? So you can it might see that that might be rejecting any internal traffic which might be having spoof IP addresses also. So if the packet is being sent from inside the network, there is which is having a source address that is looking like it has originated from outside the network, then it's very likely that a spoof packet is there and it can be dropped. So normally all these providers which are there, which are implementing the, which are other ISPs which you have, they try to implement certain kind of phenomena, like for example, ingress filtering, right? The ingress requests that you will be having, they will try to, filter them. Then they would be able to understand and they would be able to attack that. So there are solutions which are out there that can also help in, right? So there is a configuration of the firewalls that is another way, you'll see that these ISPs would be trying to work on that, right? Where it would be, utilized, So one thing that you will see that, firewall connections and firewall requests coming in where you'll see that these attacks could be stopped in from that, like the amplification attacks and the DNS amplification attacks which are there, right? So they will try to scatter all the traffic, to the point where it's no longer disruptive enough. And one other thing is how they are able to distribute the weight of the attack across the many data centers or the servers that they have and perform load balancing, because of which the service might not be interrupted and the attack might never overwhelm the entire target server infrastructure also. So that is on different steps also, a lot of the solution providers they take in that, because of which they are able to avoid these kind of attacks. So, that is few of the things where it could be there. Now similarly, just like you have the DNS attack, DNS kind of an amplification attack that might be happening, you also have the ICMP flood kind of a scenario. Like, so for example, in ICMP flood kind of a scenario, what are some of the things that you would be able to do? Now, ICMP flood DDoS attacks, is where you will be trying to disable my entire ICMP echo request pings, right? So you have my ICMP echo request pings, which is nothing but your, so ICMP is nothing but your internet control message protocol, right? Where we have seen. So as part of this, So like what happens is, we have this ping flood attack, right? So what this, where the attacker will try to overwhelm the entire targeted, an entire target device with all of these ICMP flood echo request. So this ICMP echo request, which is the pings that might be coming in, right? So it will be completely overwhelmed by this. So normally this ICMP echo request and ICMP echo requests and the ICMP echo replies that you will be having, the messages, they are being used to ping this network device, just to identify diagnose what is my health and connectivity of my device, right? And what is the connection that is being used between the sender and the device. So now when you try to flood this entire target and with the request packet, what happens? This network is being forced to respond with an equal number of reply packets. So there's a request packets that is happening, and because of which there is a corresponding response or a reply packet that might be happening as well. So this can cause this target to become inaccessible as well. So, you'll see that this is also one kind of a distributed denial of attack that we'll be trying to coming in. So in this type of an attack, both my incoming outgoing channels are overwhelmed. There would be significant bandwidth consumption that would be used, and because of which there is a denial of service. Now, how do you identify, right? So in this kind of an attack also, you'll see that the attacker might want to know the IP address of my target. Right, so in ICMP flood attack also, the attacker will try to know the IP address of what is my target is. So there could be three main categories, based on which this kind of an attack would be primarily been bifurcated. So first type of attack that you'll see will be more of a targeted local disclosed. So what happens in a targeted local disclosed kind of an attack? We'll try to have a ping flood that would be targeting my specific machine, right? There is a specific network or a specific, machine that will be happening. So in this kind of an attack, what you'll see that the attacker will try to obtain the IP address of my destination, beforehand only they will know the IP address of the destination. So that's my, something that I will always try to identify. The second kind of an attack that you will have is my router disclose kind of an attack. So in a router disclose kind of an attack, what we'll see is my entire ping flood, which is happening, will be trying to target my router, with the whole objective that I have is trying to interrupt my communications. So I will try to interrupt my communications between my machine, between my network, and because of which, the attacker also requires to have a kind of an IP address. Now, this is where the IP address, the internal IP address is something which is more required for this because of the router aspects. The third thing that you have is a blind ping. So what happens in a blind ping? It will be trying to involve any kind of an external program, right? So it uses something of an external program to reveal the IP address of my target computer or my target network, right? So that would be there. Now, this is where some of the things, will be identified as part of a ICMP. Now, why this is something that is, these kind of attacks are more dangerous. Obviously, since they are volumetric attacks, so you'll see that since there is the target device that you have, network connections that will be there, that would be flooded with bogus traffic, right? So that is, you'll see that the bogus traffics will be coming because of which the legitimate request which might be there, they could be also avoided, right? They are being prevented from getting through, right? So this creates an entire danger, a lot of attacks might be happening, right? So they primarily, that is one of the thing, and there is also a kind of a spoof or false IP address that is being used in additional to mask this entire, the device sending. So that could be done, and sometimes in sophisticated kind of things, scenarios, most of the times you'll see that botnets would be used. Botnets or some bots would be useful, would be used in, so to run this entire thing, to automate a lot of these things so that it can have. So that is another thing you'll see. So prevention steps perspective, there are different types of prevention steps that you might try to do. So one thing that you can do is you can try to disable my, so how do you prevent it? So one thing that you can do is you can try to disable my ICMP functionality altogether, right? But what happens is, this is something that will happen, but this is something that will stop your entire, entire connection. So what you can do is you can have your firewall, the perimeter firewall that can happen. So you can try to block the pings that you can feel that are not request or not required, right? So outside your network or, outside your entire perimeter that you have, you can try to avoid any of this. Now, there could be only certain kind of messages that you want to, walk them to be working for normal operations. Like, for example, you have the ICMP v6 messages, and only then that those ones which are, you can permit. So they could be permitted, so that it's able to maintain the normal operations. Now, what happens is, as I was mentioning, we can block everything. So the entire the eco reply will stop all the ICMP attacks, but it will also try to make my entire device unresponsive to any of my ping requests, trace requests, and other network activities also. Now, another kind of an approach that you can use to avoid these ICMP attacks is primarily to have my rate limiting, right? So rate limiting the processing is also another thing that you can do, you know whatever the incoming ICMP messages that is happening. So I will do a rate limiting of this incoming ICMP messages, and I will try to limit the only the allowed size that would be there for the ping request. So let's go, so we can use that, and that could be also, you can use some additional external solutions also that could be, trying to stop these from happening. So that is another kind of a ICMP flood that things that you will be seeing in this. Then we also have another kind of an attack very popular, which is your ping of that kind of an attack, right? Now itself, as the name suggests, ping of that is more where, you will be having multiple of these pings coming in, right? So ping of that is where, you'll see that as part of my the pings that is happening, right? So, there are different, you have these network combinations and all of it, right? So ping of that, it will try to explore these entire vulnerabilities as part of my fragmentations in my entire ICMP package itself. So what I will do is I will try to, there could be some kind of a malformations that would be happening, or the oversized ICMPs packets that were there, right? So this entire fragment ICMP packets that are there, some of them might be malformed or some oversized which are there. The attackers will be, crashing or freezing the target systems, right? The things. Um, Here you can see that there is a maximum allowed size for the ICMP packets, right? So the ping packets which you have. So the normal size is you have 65535 bytes, which is there, but the attacker will try to send an ICMP packet which is larger than this size. Then you'll see that the oversized packet which you have, right? That could be fragmented into some multiple smaller packets also. So as part of, the oversized packet that you have, they could be also fragmented, into multiple, uh, you know, smaller packets. Now, if you see this system, they might, whoever the receiving system is there, they will try to reassemble these fragments back. and there is into a more of a larger packet. And this reassembling process might fail sometimes because this package is exceeding this maximum size. So this reassembling process will be failing, and that might be causing also my system to crash. So the key is the fragmented package is not containing any information about my overall size because it's a fragment. So they don't know what is my overall size of the original packet, right? So the target system that has in no way knows if my final reassembled packet that you have after my reassembling, whether it is gonna exceed the overall limits, and because of which, unless it starts doing it and it becomes too much late. So normally you'll see that these would be attacks would be used done or conducted using some of my common methods, like for example you have the routers, firewalls, servers and all. So these are some of these methods to which I would be able to do it. Now, these are primarily, this is a kind of an attack which was in the initial years also when, your machines or operating systems, like since the old Windows also, it happened, right? Since then it was, identified or started with. So you'll see.
So, you said that reassembling of the fragments will happen, right? How the reassembling will happen, like based on what parameters the end device try to reassemble the packet.
Yeah, no, this is a normal process, right? Because what happens is whenever the fragmentation happens, right, that's is how your communication happens, right? So what you do is the fragment, it's a kind of a normal process where, you break the entire communication into multiple smaller packets and you try to reassemble those fragments in my target packet to, so that will basically, it's a normal process as part of my the ICMP communications. But now what we are doing is, we are trying to send these packets, these individual packets itself within those higher limits. So at a overall level, the packet which is there, the reassembling is there is a specific size for it. But what happens is when we send these packets, I'm not able to understand what is the allowed size, as part of the, whether each of these packets together is it's exceeding the reassembling size. So when I start reassembling them, like for example, if you see this ICMP packet, initially I'm not keeping a check with respect to overall bytes, but when I'm trying to reassemble, then I realize that that is oversized and I'm not able to process it, but it might be too late because the final reassembling I'm trying to go there and I'm not able to do it, and I start failing, the entire system will be failing. So this primarily in the initial days also when the TCP/IP protocol started. Since there you'll see that attackers started exploiting this limitation with respect to these systems, which the way the communications were happening. Now currently we have methods to avoid it, but in the initial days, it's some kind of a kind of an attack based on the communication medium, the communication packets across as part of my protocols. I was able to do it.
Okay.
Now there are a lot of methods, you have which can be used to mitigate these attacks, but in the initial days it was difficult. So one thing that what yeah, now these systems have started doing is this packet side validations they have tried to do, right? So this packet side validation primarily, I will try to keep on checking what is the kind of the packet sizes that is flowing in, right? So we defined what is the checks on the packet sizes as part of, a kind of a running aggregations I will be doing. So I can prevent any kind of a buffer overflow, at the at a point of throughout my process rather than only at the point of reassembling. So if there are something which are overflowing or if I feel it is exceeding the defined size, then I might try to drop or a lot of these oversized packets, right? So I can try to drop these oversized packets that can be mitigating the risk also. So that is one thing that I do. Second thing that I do is I will try to reduce my fragmentations also. So this reducing of my fragmentations is where I have certain kind of limits put in, right? So there is a uh, MTU, which is your maximum transmission unit that I define, right? And this maximum transmission unit is on my networks I define primarily will try to reduce my need for fragmentation also. So the normally the attackers will be trying to rely on these fragmentations, but if I have this maximum transmission unit defined for the networks, what I will know that some of these parameters, the maximum transmission unit, or what is my the entire datagram, how it looks like. So rather than sending it over in the form of this, I can have these parameters defined that can understand or define me what is the kind of a limit that we can have. So these are different techniques, through which I'm trying to reduce the fragmentation of larger packets that might be coming in, right? So that is one other thing that I try to define, So like for example, that is very popularly where I will try to do that. Then there are ways, other ways also solutions are able to do it. Primarily, if you see, there are, the ICMP, I can start blocking at the firewall itself, right? So what I do is you will be able to see that some of my network perimeter firewalls that could be also configured so that I can start blocking my incoming ICMP packets. I can start preventing the pings that can be reaching the vulnerable system so that I can start more blocking some of my requests coming in also. I can also start having my patch systems defined, right? So I can start looking at for some of these patches coming from my operating systems because and network devices and all, because these are something that is as part of their vulnerability that might be there. So I can start, identifying those vulnerabilities, identifying with the provider and then trying to mitigate them. So these are also some of these things that I can, do. Even in my cloud environments also, you'll see that, let's say, for example, we nowadays we have a lot of these cloud environments, right? Now, in the cloud environments, you might be having these VMs, so these virtual machines that are being configured, right? So like EC2 clusters, and you have these the VMs that or the Kubernetes clusters that will be there, right? So you'll see that these are also getting targeted these days. Sometimes what happens is, um, these VMs might be sending these malform pings and all, so that could be creating this. There could be across my VM to VM communications might be happening. So sometimes these could be also exploited by the attackers. So how these ping packets are being crafted so to, exploit these isolation boundaries and, adjacent the VMs, the compromisations might be happening. So those are also, ways nowadays which is there. So taking those necessary, there's measures with respect to patches, firewalls, so how will be able to remove or will be able to stop these attacks. Similarly, just like we have this ping of death kind of an attack there, another similar kind of an attack, which is, again, based on the same lines that is we have over here, is nothing but your Smurf attack. Now, Smurfs, you might have heard as a part of a cartoon character, but primarily this is also a kind of an attack you can see where it's something, I will try to have a kind of a spoof address, defined. I can start overloading my target device on networks, in such a way there could be with respect to not rather than normal, I will try to do it with a bogus traffic, right? So I will try to amplify the amount of traffic also, right? Because of which the entire target will be getting overwhelmed with requests and, will be getting impacted. So what it does is, again, Smurfs also uses these IGMP protocols, echo request. to overwhelm this entire device that is attacking. Now, this is primarily measured with something called as my packets per second. So how much packets per second that I am trying to send, the attacker is trying to have is something where you'll see. So here, let's say you have an attacker and you have the target, right? So what this attacker will try to do is this attacker will try to spoof my entire IP address of my target the IP address of my victim, right? Or the person original IP address. And it will try to send some of my ICMP echo request. Now what happens is routers which are there, right? They will try to get this echo request and it will be flooding to this host per the destination. And each of these hosts that is receiving this ICMP request, it will try to reply back to my source IP with something which is my echo reply packets. So this will be containing my target's IP address, and then all these responses are being sent to the victim, and because of which it will be overwhelmed with traffic, and it would be creating a kind of a denial of service. So the attacker, the target, the attacker's entire initiating ping, which is there, it is gets multiplied by a lot of factor by the host, because of which it will create amplification effect and it will be completely flooded with traffic at the target network ends, right? Now, some of the key characteristics that you have as part of these attacks is first is these are, more reflective kind of attacks, right? So like, for example, these responses which are being sourced from these systems, they hide my attacker's identity, right? So you'll not be able to identify who is my attacker exactly, because these are like spoofed again. Then amplification is something that is very much there, right? So it will try to exploit my, the ICMP echo request, right? And for traffic multiplication and all, it will happen. Then you also have my layer 3, where you see that this will be something will be happening at my network layer. It will be flooding my victims, with my ICMP traffic. Then you also see that this is more like a distributed kind of attack, because there would be many responding hosts that would be spread across my networks, right? So many responding hosts is being spread across my entire network. And something that this is something you'll be seeing that it is, this is something. So the the application amplification factor plays a very important, something very distinctive in this kind of an attacks. So the factor, how at what amplification will be being there. So there would be sometimes 20 times, 70 times amplification that will be happening, right? So this, all these hosts, the reply packets that have been sent to these victims, it is being multiplied, by a specific factor. Sometimes this amplification factor could also be greater than 100 times, right? So very large networks which are having hundreds or thousands of hosts can, also do an amplification of over by 1,000 times, right? So that is there. Then how do you attack? How do you basically defend some of these attacks, right? So first thing that you can do is you can try to disable your directed broadcast. You can start stopping your direct broadcast from happening. So you can see that the router should be, dropping these packets with a specific directed broadcast destination address. So you can start disabling my directed broadcast. Second thing is you can have my filtered ICMP as a processor can try to block outbound and rate limit some of my inbound ICMP protocols. Then there are the firewall rules that you'll see, right? So what kind of specific firewall policies and all you can start putting in, so that is something that you can do. Then switch port security is also something there, right? So as part of my how you can start limiting the number of MACs per switch port, right? Or the virtual LAN networks that would can be done to create my prevent outflows. And then you can also try to use some of my services, the mitigation services and solutions that can be also try to utilize to filter out, detect and filter out some of these attacks, right? So you'll see that this is where these smurf attacks are also something, and these attacks also keeps on evolving because since these are IP address related attacks, right? So one thing is for the IP enabled devices, the different types of new devices that could be identified, right? So across your IP enabled devices, across your public cloud, across your, the IPv6 protocols that are which you have, right? So you'll see that these attacks keeps on evolving. The attackers will be continuously evolving this entire, these kind of attacks. Over the years also it has happened with new protocols coming in, with new attacks coming, methods coming in. These kind of attacks are also uh, keeps on getting, flooded with these kind of. Okay. So these are the different types of attacks that we have as part of it. The next kind of a component that we have seen, right, as part of a common factor as across each of these attacks is nothing but your entire botnets, right? So normally, if you see any of my these attacks that we were able to see, there is a kind of a common factor that you can identify where these kind of attacks were being able or being initiated. So your botnets are primarily, as we were seeing, are these networks which have been composed of the compromised machines or the bots that the attacker will try to control and might be using it at a specific for a specific purpose. So these botnets or the bots that we will be seeing, you know that these machines or the infected servers or the infected machines that you will see, they will primarily work together to carry out an entire attack together. So it's a combination of two words. You can see botnets is more like you have bots and you have networks. So a combination of bots and over the networks is your botnets, right? So like these are robots and this is networks. Nets for networks stands for network. So that is the different types of it. So if you see, normally the attacker will be trying to build a bolt, trying to build a botnet, by trying to take a control of my overall large number of machines. So wherever, you can obviously try to build a botnet using some of your local machine capacity or capabilities. Normally, you'll see that a very important thing that gets used for your botnets are your malwares, right? So these primarily botnets will try to target your, target device. There would be some kind of poor security controls that they will be having, right? So that they will try to explore. You know, that is something that they will do. Then you see that once this malware gets installed on this machine, it will try to monitor for the instructions that will be there, across architecture. So there are different types of protocols that it can control, command and control architecture that it can have that could be exploited or that could be utilized as to create these botnets, right? So, for example, you have these data that might be posted on the websites, right? Then you have the social media channels, and all that could be used, right? So what happens is when these command and controls signals, will be coming in, the botnet will be executing these command and control signals, and you will see that as part of the command and control server, there would be communication that would be happening. Right, so there could be automation of a lot of different types of attacks where these botnets could be utilized by these attackers, And like for example, we have vulnerabilities identification perspective. So we will try to identify these vulnerabilities also within. So you can see this, these malware identifications or some of the other cyber attacks. The identification could be using these vulnerabilities. So I can start searching for any of these vulnerable systems. I can start exploiting them, right? Then we have these, the malware deliveries, coming in, right? So, for example, some of my uh, botnets are being designed to be self-spreading, but it could be increasing the power of my maliciousness, scope of my malicious network. But after identifying this vulnerability in the targeted segment, what we can do is we can have the bot, we can exploit it, we can use it to infect my target system also. Then we can also use it for multi-stage attacks, right? So multi-stage attacks is where in addition to delivering my own malware, so I can sometimes use these botnets to distribute the other types of malwares. Like for example, a botnet, I can use it for downloading and installing an entire banking Trojan or ransomware as well. I can also use it for some of my automated attacks, right? So for example, some of my various type of automated attacks I will try to do with respect to my targets, so I can start using this kind of things. Some of my botnet attacks that we have seen already, like for example, for DDoS, we will be using or password attacks, right? Where I'm trying to have my credentials, identifications, and credential, you know, uh, they are taking those credentials and some of these breaches, right, as part of a dictionary attack and all. I can start identifying the password. So that those we have seen. Then phishing is also where, you can see that I can start using these botnets to have support or use it for my phishing attacks, right? Then you see that I can also use it for some of my frauds that I want to do in the financial systems, right? So that is like, for example, the credit card data, I can use it, and store it through these breaches and can then execute it as a kind of a across my transactions to all the across all the cards and all, right? So that is there. It could be also used it for like cryptojacking. So cryptojacking is a phenomena where, I can have these, use it during your cryptocurrencies, right? So like in your financial, specifically in your cryptocurrencies as a use case, I can start mining the crypto coins and, I can start using it. So those some things that you can also see. So since botnets are posing a lot of different threats, different types of threats, specifically, so you need to identify some of these bots over a period of time continuously and try to see that it's something that you don't install, don't allow as part of this, right? So those are some of the methods that you can do. You can start looking at, where there could be methods there again, like for example, since it is the entire network, the entire the bot herder is also, you can also look at it as a bot herder, where there could be there. Now, different models are also existing with respect to your botnets. So, what are these different types of models? We'll just spend some time to understand some of these types of models. What are these different types of botnets that are being also existing. Okay, so we'll spend some time to understand different types of uh, what are my these different types of models of botnets that are being available, right? So yeah, the first
Yeah,
category of
brilliant.
yeah, sure. The first category of botnet type of model of botnet that we have is more of a starred uh, we have my star network topology model, right? So just like, even for your data perspective, you have the star schema based model and all. Yeah. So like this is more where you have a hub and spoke kind of a model, right? So you have a star network, where what you have, it's like some more like a hub and spoke within the entire machine. So you have a host, this is connected to a hub. At the center of the network, you will see that all these multiple machines are there. So there you have a machine one, you have a machine two, you have a machine three, and you have a machine four, right? And then in the main center, you have something like a hub. So primarily this hub is being used for sending this message for each of these machines, right? Now, data on this star network is mostly being channeled through the central hub, right? So what kind of happens is in this kind of a botnet kind of a model, if you are able to hijack the entire hub, you are able to have a control over the entire the connected connections that you have. So that's a more of a it's and the hub identification and hub saving is something is becomes more important, right? The second kind of model that you have is multi-server topology kind of a model. So in this, what happens is very similar to my star network, but rather than only one server sending and receiving all this data to all this, what you have is we have a chain of servers, right? So this hub is now also divided into multiple servers. So within this, we have uh, server one, server two, server three, and now these are getting connected, right? So we have a chain of multiple servers, right? And then what happens is, these are getting all connected into through the entire devices, right? So you have multiple devices that would be connecting, right? So very similar to my start. The only thing is I have rather than having a single hub, we have now a network of my hubs or network of my servers. Then we also have the network, the hierarchical network topology kind of a model. Now, in a hierarchical network topology kind of a model, what happens is we have the a kind of a hierarchy, right? So there are three main layers that you'll see. You have a core layer, you have a distributor layer, and you have an access layer, right? Now, as part of each of these layers, you'll see that there is a hierarchy of machines that is there. Now, the server that is sending and receiving the data using my bots. So I will try to send and receive this data to the other bots which are lower in the hierarchy, right? So we'll have multiple of these connected, and then within this you have some other devices, and within them this would be connected to some of the other devices. So there is a kind of a network hierarchy that gets established. So there is a kind of a separation across these different layers also that would be able to see. Similarly, you also have some kind of a model where is like which is also like a peer-to-peer model, right? So peer-to-peer is where the botnets are involved in each of these devices which are connected to the network. In the earliest cases, you saw that it is more like the hierarchy level. It might be there, but then you can see that each of these devices might be connected to the network, which might be operating independently at both a client and a server, right? So then these devices might be coordinating with each other. They might be transmitting and updating this information across the entire systems, right? There might be not be any centralized account or botnet structure that would be coming in as well. So again, this is a kind of another kind of a model that could be available or that could be present. Now, these different types of models are being used for different types of botnet attacks, right? So one kind of a botnet attack that you have is where you would be able to see based on the type of different types of characteristics. Like for example, um, what kind of how many number of bots are being used. And so based on that, the different types of criterias, these are also further classified into multiple types. So you have a bot master kind of an attack where, for example, you have a single leader or an individual who would be running this, the botnets, right? So these botnet functions which you have and all, they would be remotely launching this, these attacks and all. So this is a bot master who manages or controls this entire thing. So these botnets primarily will be installed by this bot master, and then this bot master will try to control it, will try to get these. So all the configurations and all would be done by them, right? So like for example, using the proxies, and the IP addresses or those kind of things is something that we'll be doing. So this bot master will be, it's just like, you will be managing all of these attacks happening, right? Then you also have the zombies attack. So this is also something that you might have heard about, where you'll see that the machine that is being connected on the, with the internet will be controlled by the hacker or a malware, right? So this bot might be installed in the machine. So you have something like a Trojan horse as a zombie, so primarily the entire your machine will start working like a zombie, right? So the entire machine will not respond. The primarily it would be controlled by someone else. Like in a zombie movies, you might have seen that, you give an order and they start following. So it would be something like that, your machine will be completely and responsive to any of your commands. Then you have the spams, right? The spamming aspect where you'll see that there is a spam bot that might be useful. They will be distributing the spam emails to the machines, so there would be like, some kind of advertisements coming in, right? So, like for example, for fake antivirus software or counterfeit goods and all, so you'll see that there would be some kind of a machines, so this is something where you see these $1 million wins and all this kind of things. So what they will do is they will use a botnet. They will infect the entire machine and will send out some spam emails from their devices also. So, so that is something it gets installed on your machines and could be stopping doing all of this. Then you also have these spywares that could be useful, for using, that would be spying your entire machine. They would be based on your automatic clicks or online advertising. You will see that, these clicks can start happening, and the spywares will be looking into whatever you're doing, trying to capture those credentials and all. And then based on that, they would be utilized for stealing money, taking out or performing transactions. That is as part of it. Then similarly, we have something called initial days. We used to have these dial-up modems, right? So in the dial-up modems, what used to happen is these dial-up modems through which the dial-ups with dialing numbers used to be different. So dial-up modems is normally used where from your machine there would be phone calls that would be there. Like for example, your machine has been tied up to a phone connection and all. So it will try to force the user to change the number and all, and try to call on for a point of win. So you'll see that there is a very high phone bill that is coming up because in your machine, on your machine, the which is connected to your phone, you'll see a lot of calls started getting up, right? So these kind of things, you'll see that it is not only like this is there for your local laptops and all, but it could be there in your phone devices also. So that is also something where you'll see these dial-up bots also come here, being used. Then you have the web crawlers. So web crawlers are primarily, you have they would be crawling through the web spiders that you have, right? You will be the bots that might be there on the engine. So you'll try to see that it would be downloading and indexing the website content. And the whole objective that this kind of a bot is using is to try to figure out what each of these website is all about. The site could be matched against the query that might be received from a search engine, and they will try to crawl the web. They will try to grab of information from websites. They can organize, categorize it, and they can start using it. So disabling the botnets is very important. So you know where to, based on this kind of the botnet attacks, you can see that the control, you can define a kind of a botnet control center or a, software that can start looking into each of these infections specifically. They can try to limit the type of data that is getting shared in case, try to identify. A lot of these antiviruses, they have these, to identify the zombie spywares and all in case if it is sitting in your machine, and it will try to keep on continuously removing them. So in the backend, you will see that these antivirus keeps on executing and running and identifying them and deleting these, right? So that will remove a lot of these vulnerabilities from your machines, right? So that is a very, very interesting way how you can see that, there. And then there are awareness campaigns that you can do. Like, so for example, whenever in an organization perspective, few things that you should do to basically try to avoid, devices or avoid the softwares and all which are having which are not trusted, which you don't trust and all, and always download it from authentic websites. A lot of times you'll see that this might be same there in some other websites on also free, which is showing free, and also that is something that you should not do. Then the email attachments and all. Be very careful what you're trying to open, right? Because these attachments might be having bots, and once you click on them, they might be attaching, and they might these might be getting installed, right? So those kind of things. Try avoiding any kind of click links also. Avoid these links that you are not very sure of, and you end up clicking them, and the way it is being designed, you tend up or end up fall prey to those, right? So that is the so in antivirus software, a lot of times they help you a lot in those kind of things. You might not be able to do a lot of this one by one bits and pieces. So you can see that you can have these antivirus software that can give you in avoiding a lot of these aspects. Okay. So these are something that we have seen. So now we have the last section that we have. I think what we have done, we have not taken a break till now. So what we can do is we'll take a quick break for 15 minutes. And after that, what we can do is we can continue with the last segment. I think that is primarily on the what are the different steps further that we can have to understand, these some other few categories of the attacks that we have left in. I will use that. I will show you some of these solutions and tools, and that is something that we'll do. And then we'll start with the next topic, which is on the web application attacks that we'll also start. Okay. So let's take a
Okay.
quick 15 minutes break. Yeah, I think should be okay.
Yeah, sure. Yeah.
Okay,
We'll do
sure.
that.
Okay, all right. Thanks. Okay, welcome back. So we'll get started. So now we're going to look at some of the possible type within the examples as part of some of these attacks. What are some of these, within the, DDoS attacks categories? Some of the other ones that we have, the denial of service attacks. So one type of, and then we'll see some solutions across that also. So one type of attack that we have is a more of a reflected denial of service attacks, right? Now, reflection amplification attacks or reflection denial of service attacks is more where, this, I can see that there is a kind of an amplified response which is being sent to the, entire machines. Like, for example, you have now an attacker. This attacker is trying to spoof my uh, you know, the target IP address, and then it is trying to send some kind of a request for some information, primarily with respect to the UDP or in some cases the TCP aspects. Then the server will try to respond to this request. It will try to send an answer to the targets. Okay. Now this reflection, we're using both these protocols, will be used, right? So the reason why it is called as a more of a reflection attack, because you will see that the same protocol will be used in more both of the directions, right? So same protocols it will be used. So that's the reason, So let's say, for example, if it's an UDP or it is a TCP based attack, where that could be targeted. So based on that, you can use adequate of these protections, that can try to mitigate, that can provide you steps to start mitigating these kind of an attacks. So normally amplification attacks, if you see these the reflected DDoS attacks primarily, as it is a more of a amplification attack, where you'll see that there is again, because there is a huge number of packets to study that would be coming up. So here you can see that again, the magnitude of this attack will be very high. There would be large number of packets that would be coming up, that would be used. So the more prevalent forms that we will have is like, for example, the DNS, NTP, SNMP attacks, SSDP attacks, or some of the other UDP or TCP kind of attacks that you have. So these are like just a few of the examples. Now, how do you identify whether it's a kind of a, reflected attacks that is happening? Now, reflection primarily are quite easy to or easily identified, because it's firstly it's a large volumetric attack. So you will know that if there is a kind of huge number of requests and response that is happening. Similarly, because there is a huge substantial flood of packets with the same source, right? It will be the same source and it would be targeted to a single target, right? So it will be there, it would be easily identified as well. And these incoming packets primarily, you'll see that rarely it will be sharing kind of a same destination port number also. That is why, this kind of attack is very easily identified, right? These incoming packets that you have rarely will be sharing the same destination port number. So these kind of attacks, that's the reason, will be much easier to identify. Now, attackers often will use multiple vulnerable services also at the same time, because of which it could be combined together into an extremely large attacks as well. So how do you defend against these reflection amplitude amplification attacks? So normally what you do is, there is no clear sign, could be it could be some kind of an ordinary servers that could be being compromised and all. So the attackers are being attracted.
Saurabh, you're sharing your screen share was stopped in case if you're
Ha ha
sharing
ha.
that.
Yeah, yeah, yeah. Sure. Thanks for highlighting that. Actually, I didn't realize. Okay, I'll just start sharing. So these
Can you
kind of
continue?
attacks. Yeah, yeah, sure. So these attacks will require, might not require so much. So you can see that the primary defense that these kind of attacks will be to block some of these. Once you start identifying them at a point in time, you start blocking these spoof packets, right? These spoof packets which are there, you will start blocking them. And sometimes these attacks will be coming in from your legitimate sources as well, right? So it will be using some of your trusted services, like you have the DNS, you have your NTPs, their trusted devices will be there. So it might be sometimes difficult to tell which is the one which is a genuine workload or whether it's a kind of a spoofed workload. So, whenever the service is coming under attack, this legitimate traffic might be forced to retry these responses, because of the slowdown in the services, because of which, it might be causing, retries to be falsely identified, so that is another thing that you can see, um, falsely it would be identified as a DDoS attack, right? Okay. So that is one thing. Now, there are different types of steps we can try to look into. Like this, primarily, just like for the other methods, one is the rate limiting methods that we can do. So you can apply it to destinations or sources. We can try prevent systems from being overwhelmed. And destination rate is something that I can, the destination rate limiting, I might be inherently impacting, it might be inherently impacting the legitimate traffic. So making this is a more like a less desirable approach. So rate limiting is most often considered more effective because it might be restricting the sources based on the deviation, from an established policy. The second thing I can do is I can start blocking the ports, So one thing I can do is I can start blocking my ports that are not required. Okay. That can also start reducing the vulnerability attacks. So this will not try to prevent any on the attacks on the ports and, can be used by both the legitimate and attacker traffic. The third thing that it can do is you can start having some of your traffic signature filters. So these traffic signature filters could be used to, identify these repetitive structures. So that will be help you to identify whether there is an attack happening also. It will be tell you. And then, one of the thing that you can start doing is you start filtering and doing it, but it might be also impacting the genuine request that is coming in, right? So because of which performance might be impacting. So one thing that there could be some threat intelligence services that you can start deploying. These threat intelligence services, could be useful for identifying these vulnerable scanner servers, which are there. Which could be useful for blocking these IP addresses of these vulnerable servers, right? So it's a more of a proactive step or a proactive approach that you can engage or you can use that can start providing you more precise mitigation steps, right? So these are some of the methods that also you can utilize as part of your the entire reflected DDoS attacks, right? Then you also have another very interesting kind of an attack. So we have seen one of these attacks, but this is a kind of a subtype within it, which is nothing but your zombies attack, right? That we have seen. Now, these zombies attacks that we have seen, primarily, we understood what is it. Now, this is a subtype within your zombie attack where we also call it as a pulsing zombie attack. Now, the whole reason why, we are calling it as a pulsing zombie attack is because there is some kind this zombie which is there. It is intermittently, sending burst of my malicious traffic request. Okay, so this burst which is happening, it is intermittently happening in the form of a pulses. So this is again, where as compared to in a normal attacks, which is this is something where it will be continuously coming in, right? So these these zombies which are there, these are primarily will be taking care, so in just to make your entire attack more difficult, right? So what we'll do is these zombies which I am doing, it will try to do the as your traditional zombies which are there, as we have seen, they will be working like that in an intermittent way, right? So intermittently, what they will happen is they will work because of which detecting or stopping them might be much harder. Okay, so like for example, a pulsating zombie might be alive and might be sending a kind of a denial of service railway traffic for 10 minutes, right? But what happens is this 10 minutes could be intermittently increased, in multiple batches to 40 minutes. So this same pattern keeps on repeating across these different machines, because of which the attack might be becoming more difficult. Now, once these devices are alive, the detection might be easy because a lot of traffic is identified from there or where it is coming. So these pulsating zombies or pulsing zombies are primarily, you will be seeing that, uh, because since they are slow, they are gradually, you can do it, but, you'll see that it would be through irregular burst, so irregular time, you will be able to see that they would be these are irregular burst of traffics could be identified or sent. Now, another kind of interesting kind of attack that you'll see, which is what are some, so these are some of the ones that we have seen. Now, how do you basically use? What are some of the tools that are quite, when it comes to the DDoS attacks, right? What are some or denial of services that is there? What are some of these ways how you can start avoiding them, right? So one of the way is primarily using your H-pings, so in your Kali, when you go, you have this, the H-pings that can help you to understand, so within that, there are certain ways how you can identify. So you can use, I can identify the number of packets that are coming in, the number of packets that will be sent, because of which you can identify what are the packets that are being sent. You can identify what are the posts that are being targeted and, what is the mode that is being used for that. So that is the first thing that you can use. The second thing is you can use is Hulk, another solution which is there. So let me just show it to you. So the documentation of Hulk is available here, so you can use this. So this is a Hulk denial of service. You can see that the tool. So you can use it as part of your Python packages. So the, in as comparable languages, which is there, you can see the commands which are there. So again, it also uses a lot of thousands of threads, if it can automatically, it can launch an efficient attack against the web server. And you can try this. You can just use this as Python script. You can, launch this, and then you can see whether your system is able to identify, right? So these are the two more common ones which you have identified. Then we have the orbit ion cannon, right? So within the orbit ion cannon, we have two more main types. We have a low orbit ion cannon, and we have the high orbit ion. So this low orbit ion cannon and we have the high orbit ion cannon are also some of the tools that you can use. So the low orbit ion cannon primarily it will be supporting your UDP, TCP, and HTTP GET request, GET packet floods. And then you have the high orbit ion cannon. Primarily, it might be supporting only the HTTP, GET, and POST attacks, right? So that is the main difference between them. But both could be controlled by the IRC. So you don't need to install the client applications. The tools could be made available, right? So you can have this. And, you have some of the other solutions which are out there that also could be useful in looking into that. So one such solution is primarily your, like for example, you have the Thor's hammer, right? So you have just like you have Thor, who is having hammer. Similarly, we also have Thor, right? So Tor hammer is also, Tor's hammer or Tor hammer is also one solution that you can use against, the Tor network, so that could be useful. So normally a solution provider, like for example, SourceForge, Net and all, there are a lot of solutions which they provide. So you can use that. You can, there are some of these solutions or projects which are there in the SourceForge So you could be utilized, but again, you need to verify whether they are authentic or whether they are, one thing is these are like reliable websites that through which it could be there. Right, so you can have these. Normally, these are different types of for each of the attacks. We have seen how do you basically go ahead, try to protect, each of these different methods. How do you basically limit and have it? So each of these you can also have um, some of these methods. So there is an industry standard which is Center for Internet Security, if you know the CIS, which also publishes a lot of these benchmarks. So you can download these benchmarks. The CIS benchmarks is also one of a reference point that you can use. So that helps you to understand what are some of these things, and across your different operating systems and across your different OSS and systems and all. So they have some good practices which they publish as an industry practice. So CIS benchmark list helps you to understand. So you can download these benchmarks and you can, once you just register, fill in your details. Provides across your different solutions. So as an industry solution, as an industry use case, you can have this identified. And then a lot of these vendors which you have, right? So they would be also providing a lot of them. So rather than the some of the specific things that we have spoken of, a lot of these are something that comes in with some of these, antiviruses and security solutions. So that is another one good way, having those firewalls and the WAFs and all the web application firewalls and, those solutions. That can also helps you to avoid these kind of attacks happening. Right. So that is another things that you can look into to avoid that. Okay, so I think this is something that we saw today, primarily on the entire chapter of denial of service. So we have seen the different types of attacks under the denial of service and what are the mitigation steps that we have under all of them, right? So quite interesting, different because each of them has a different way of attack, and the based on that we will have to have some different mitigation steps for each of them. We will have to look into each of them. Okay, so I'll stop sharing now.
So under HPing, can you give like couple of samples of example commands and all if you have if you know what will be the behavior of various things for the HPing.
Uh, I mean, I didn't get you.
So for the for the HPing to work, right? Like we how we
Okay.
use the ping commands, like for the HPing
How do you
commands or the
write it, the
HPing tool.
commands? No, so
Yes.
that is something I was showing you. See, this when you go, right, HPings, for example, let's say, for example, you have this. So you can explode this.
Oh, your screen sharing was stopped. So okay. So
Yeah,
you're
yeah,
saying
yeah.
that
No,
okay, go to
I'm
the
just showing
the
you
link and
1 minute.
okay.
Like for example, you have this Hulk DOS, right? So when you go through the documentation, there are steps directly mentioned. How do you basically go ahead look into? I'm not going through each of them one specifically. If the reason is, then this is something that it will take a lot of time to go understand, install it, things like for example, even HPing under your Kalis, right? So when you have HPing, let me just show you how do you basically go it. Let me just. Yeah, so this is the entire documentation for HPing. So you can see that how it is being done, so HPing creations for that matter, how it is being utilized, how it is being written, what are the syntax of the commands that you have, and then what are the different sets you can see within that. So HPing 3 hyphen H, so hyphen C will give you the packet count. It will tell you the number of packets that will be sent in. Then you have, let's say, hyphen S, you have like that. You have hyphen N, which will give you the details. So like this, you need to have this first available under root Kali, and then you can have this, you can just try it out that way. It's very straightforward. I mean, there is nothing much in this. You just need to have this up in your Pali setups, right? So that is something. Once you have it, then this will be useful. This will basically help it. So you can just have a sudo apt install hping in that, and you can just you first have to have Kali installed there. So once you have this app install hping, this will get installed hping in that, and then just type in hping with these options. So you'll get these network packets. Now, how do you identify these as network packets? So if you see this example over here, it will tell you, what is the number of packets that is being sent, what is the kind of a response code that we'll be getting in, right? So let's say, for example, hping this is setting or telling you what is 28 headers, and so those will be there. Now there are different modes in this. Let's say, for example, there is a flood mode also, which is available. So if you see this, there is a different modes like -I, and then you can see that -F with that. So it will tell you like in flood mode, it will send the packets as fast as possible in a faster mode, or alias that you have. There is a specific interval you want to send, so you use this parameter. So based on that, you will be seeing that what is the kind of a response that is coming in over here. So you can see that, what is the number of packets that were being sent, what is the header, what is the time that was being utilized using it.
Okay.
Like this, you can use this, just try it out the other ones also. The Hulk DOS attacks, you can do a sudo docker, build it on a Docker file and then execute it. Also, that is something you can do. The documentation is there, just it's about just trying and testing it out, so that is the whole thing.
Okay,
Okay.
got it. Yeah, we'll do that.
Okay. So I think we are good with the denial of service attacks also. So I think the other topics that are still remaining. So we have pretty much the ones that are there. So we just need to cover a few more things, which are web application attacks, maintaining access. We have covering the tracks and tunneling, and the worm bots and botnets. So I'll stop here for today. I need to catch a flight. I have my flight in order. Tonight I have my flight, so I'll have to go
Okay.
to the airport. So what we'll do is tomorrow I think I'll cover the complete thing. So we'll try to, because at the back of my mind I just need to make some arrangements and all
No
in
worries, no worries. Yeah,
3 hours from
we
here.
can
Yeah.
do that.
Yeah.
And
So
yeah,
we are
like
anyways right on track. So I think there is no problem in that. We are anyways on that track. So you can utilize this time. I'll give you the deck for today. You utilize this time, just go through it and just do some reading till then. Tomorrow, I
yeah,
think, anyways, we'll be connecting. So we will be continuing that, and we'll be.
sure, sure. Thank you very much.
Okay. So you
Yeah,
have a nice
thank
day. You continue.
you
I'll
too.
just go and
Yeah, no
make the
worries. Have a
arrangements
nice
because I'll
flight,
have to leave.
and yeah, we'll meet tomorrow.
Yeah, yeah, sure. All right, cool. Sure. So we'll have tomorrow and on Saturday, right? Sorry, tomorrow is Saturday. So tomorrow we'll meet, and then Monday, Tuesday, Wednesday, we have 4 more days, right?
Yes, I think yeah.
Yeah. Yeah. So today is the seventh day. No, today is what?
No,
Yeah,
today is the sixth day, right?
sixth day, right? So we
Yeah,
still
yeah.
have time. Right. So we only have 4 topics to left. So I think that we will be covering in the next 4 days.
Okay, cool. Yeah,
Okay.
thanks.
I'm sharing this on email with you, so you can just go through it and you just revise it. All right.
Okay, okay, sure. Yep, thank you.
Okay, bro. Thanks. Thanks, again. Take
Bye bye.
care.
Have a nice day.
Bye.
Bye bye.
Yeah.
Good night.
Thank you. Bye. Good night.